Okay, question 7a goes like this. There is a train traveling to the west and another train traveling to the east. Some of you assumed that train A, which is traveling to the west, was here, and train B, who was traveling to the east, was here. The point is, if the two trains are like this, they are moving away, so they will never meet. That means that we're not going to use this. Instead, we're going to say, which makes more sense, that train B is here traveling to the left at 70 kilometers per hour, and train A is here traveling to the east at traveling to the west at 60 kilometers per hour, and the units here, kilometers per hour. That's just to clarify the position of the two trains. So this velocity, 70 kilometers per hour, is the velocity of train B relative to ground, and this is velocity of train A relative to ground. Again, because they are not saying anything different, we can assume that the velocity that they give, 70 and 60, are both velocities relative to the ground. And what we need to find is the velocity of A relative to B. That's the question. So if we go to the equation of relative velocity, we see that velocity of A relative to B will be equal to velocity of A relative to ground minus velocity of B relative to ground. Again, I write A first because it goes first, and B second because it goes second here. So I don't have to do the vector thing because they are all along the same line. We only do the vector analysis when we have one vector pointing like this and another one pointing like this, or something different. But because all these vectors are along the same line, there's no need to do the vector analysis. So I have the equation. I'm just going to put the values here. Now, one thing to remember is, well, the velocity of B relative to the ground is 70, and the velocity of train A relative to the ground is minus 60. The minus means that the train A is moving to the left, so we should include that in the value of that we're going to put in the equation. So velocity of A relative to B will be velocity of A relative to ground, which is minus 60, and then minus velocity of B relative to ground, which is 70. So the velocity of A relative to B will be minus 130 kilometers per hour. Okay, so that is the question, that's the answer, sorry, for part A. Now I'm going to do part B here because it's very easy. Part B is, what is the velocity of B relative to A? So because we know that A relative to B is minus 130, then the velocity of B relative to A, which is like the opposite, this is AB, this is BA, will be also the opposite. So it's not going to be minus 130, but it's going to be positive 130 kilometers per hour. You don't need to do the operation for this, because when you have this value, you can say that the opposite velocity, BA instead of AB, will always be opposite too. So if this one is minus 130, this one is 130, and this is your answer for part B.